All right, today we're diving into something that's way more than just a tech level tactic. We're talking about network mocking. And we're going to break down exactly why this has gone from a niche trick for engineers to a core business strategy you really need to be thinking about.
So, let me ask you this, and it's really the big question for any tech leader. Is your ability to ship software holding you back, or is it your secret weapon? Because how quickly and reliably you can release high quality code, well, that's how you measure a great engineering team. But what if the biggest thing slowing you down isn't your code at all, but everything your code depends on?
So here's the plan. We're going to walk through the hidden costs that are probably killing your pipeline right now. Then we'll talk about a strategy called isolation, get into the right way to do it architecturally, and of course, break down the actual return on investment. And by the end, you'll see this as a genuine strategic asset.
Okay, let's start with the root of the problem. Everything today is interconnected, right? Our apps are this web of APIs and external services. And while that's great for building things fast, it also creates this invisible and often unmeasured risk to the business. It's a huge strategic liability just waiting to bite you. Now, this right here, this is a big one. It completely flips a common assumption on its head. We're all trained to think, hey, a test failed must be a bug in our code. But the reality is, most of the time, the problem is somewhere else entirely. A flaky test environment, the back-end team doing a deployment, some third-party API going down. And that's not just an engineering headache, it's an incredible amount of time and money just going down the drain. I mean, we've all seen this list. Every single engineering leader knows these culprits. The staging environment is down. Again, the backend is deploying, so everything's broken for an hour. A third-party API you rely on is rate limiting you. Each one of these things can grind your entire CI/CD pipeline to a screeching halt. And your developers are stuck chasing ghosts that have nothing to do with the code they just wrote. It just crushes morale and kills your speed to market. And this slide just lays it all out. It's a tale of two worlds. On the left, you've got chaos. It's fragile, it's slow, and it's unpredictable. But on the right, you have a system that is deterministic, fast, and gives you complete control. Making that jump from the left side to the right side, well, that's the strategic shift we're talking about today. Okay, so the big question is, how do we get there? How do we make that shift? The answer lies in one simple but really powerful principle: isolation. It's about strategically and deliberately cutting the strings to all those external dependencies during testing so you can finally get back in the driver's seat. At its core, mocking is a really simple idea. You're basically creating a stunt double for a real service. So instead of your app making a live call out to some database or a third-party API, it talks to a fake version, a simulation that you control 100%. It does exactly what you tell it to do every single time. And this simple concept creates some serious business advantages. First off, speed. Tests that used to take minutes now run in milliseconds. Then you get reliability, because all that external flakiness, it's just gone. Then comes control, the power to test literally any scenario you can dream up. And maybe most importantly, you get focus. When a test fails now, it's a real, actionable signal that there's a bug in your code, not just more noise from the environment. Now, this next part is absolutely critical. It's not just about if you mock, it's about how you mock. This is a huge architectural decision. There's an old, clunky way of doing things that creates its own problems, and then there's the modern approach that actually solves them. So on the left, you've got the old method, which is often called patching. You're basically reaching into your application's code and manually hijacking things. It's messy, it's fragile, and it usually breaks as soon as you update a framework. But on the right, you have the modern, far superior approach: network-level interception. This works at the browser level itself. Your application code is completely untouched. It doesn't even know what's happening. And that's what makes it so robust, so reliable, and totally independent of whatever framework you're using. The process itself is actually really elegant. Your application makes a request, just like it normally would, but here's the magic trick. Before that request ever leaves the browser, a tool at the network level intercepts it. It checks to see if there's a mock set up for that request, and if there is, it just serves back your predefined response. Your application gets the data and has absolutely no idea it didn't come from the real API. It's completely seamless. Okay, the tech is cool, I get it. But as a business leader, you're asking, what's the actual return on investment here? So let's talk about the real, measurable business impact when you adopt this strategy. How about this number? 60%. Teams that implement this correctly have accelerated their release cycles by up to 60%. And that's not some tiny optimization. That is a fundamental change in your development velocity. You're removing the single biggest point of friction in your entire pipeline. And that is a massive competitive edge.
And what's really exciting is that this strategy unlocks capabilities that were just impossible or way too difficult before. You can finally test those nightmare scenarios on demand, like what happens when your server goes down. You can reliably test every weird UI state, like what a brand new user sees. You can run your payment flow tests 1,000 times without hitting Stripe and paying a single cent in fees. And maybe the biggest win for productivity, your front-end teams are never blocked by the back-end team again. They can build against a simulated API and just keep moving. So when you add it all up, the business case is crystal clear. You get a much faster time to market because you've eliminated those pipeline blockers. You see real cost savings from not hammering expensive third-party APIs. Your product becomes more reliable because you can actually test for failure. And your developers are just plain faster because they're spending their time building features, not hunting down ghosts in the test environment. So let's wrap this up by elevating this whole idea. We need to stop thinking about this as just another testing tool. What it really is a foundational piece of a high-performing, truly mature DevOps culture.
And hey, you don't have to take my word for it. All the industry reports from places like Google and ThoughtWorks, they all say the same thing. The top two factors that define elite DevOps performance are the reliability and the speed of your automated tests. Network mocking is one of the most direct, high-impact investments you can make to improve both of those metrics. It's a massive lever to pull.
This quote just nails it, doesn't it? Mocking used to be a nice to have, something for a team to do if they had extra time. Not anymore. In today's world of complex, distributed systems, it has become an absolute necessity. You simply can't keep up the speed and reliability you need to compete without it.
And that's the paradigm shift. We're moving from a passive, almost reactive world of testing where we just cross our fingers and hope the environment is stable, to a proactive model where our engineers are in complete control. They dictate the state of the world to test their systems with surgical precision.
So I'll just leave you with this final question. Is your current testing strategy fighting a losing battle against the reality of a modern API-driven world, or is it actually designed to thrive in it? Because embracing network mocking as a core strategy isn't just about better tests. It's about building the resilient, high-velocity engineering organization you need to win. Thank you.